Hi everyone. In today's class, we'll see the concept of how to convert one flip-flop to another flip-flop. So means we can say that simply conversion of flip-flops. So if you would like to convert one flip-flop to another flip-flop, you have to follow basically 3 steps. First step is you have to draw the characteristic table for destination flip-flop. So what is the meaning of destination flip-flop for which you are trying to construct? See, if you would like to construct a flip-flop from T to JK, I can call JK as destination flip-flop. If I say JK to T flip-flop, I can call it as T as destination flip-flop. What is source flip-flop here? T is the source flip-flop for the first one. For the second one, source is the JK flip-flop. So for the destination flip-flop, you have to write the characteristics table. I hope you know the characteristics table for all kind of various kind of flip-flops. And second one is you have to write down the excitation table for the source flip-flop, or I can say for the given flip-flop, and you have to follow certain procedure for this, for the present state as well as the next state. I will try to know what is this things in the explanation of the example. And third step is you have to derive the expressions from the given inputs, and you can able to construct the final circuit. So these are the 3 steps you have to follow in order to convert one flip-flop to another flip-flop. For example, let me try to convert JK flip-flop to T flip-flop. First one. Okay. So what is the first step you have to do? If you would like to convert JK flip-flop to T flip-flop, T flip-flop is the destination flip-flop, JK flip-flop is the source flip-flop. So for the destination flip-flop, you have to write the truth table, or I can say it in other words as characteristics table. So characteristics table of the T flip-flop is, T flip-flop means what? Toggle flip-flop. So you are going to have one input and present state and the next state. So when you are going to have the one input and the present state as another input, so what might be the possibilities? 0 0 0 1 1 0 1 1, right? And T flip-flop means toggle flip-flop. So you can go through the earlier videos so that you can get the idea how the characteristic table of T flip-flop is constructed. When T value is 0, it is going to act as a latch state, meaning that the present state inputs will be acted as output for the next state. When T value is 1, it is going to be toggled, meaning that complement of present state will be acting as the output of the next states. So this is the corresponding characteristic table for the T flip-flop. So first step is T flip-flop done. And the second step is you have to draw the excitation table for the given flip-flop, right? What is the given flip-flop here? JK flip-flop is the excitation table you have to draw. So for JK flip-flop, if you are going to write, so excitation table means we are going to define the inputs from its outputs, right? So present state is given, next state is given plus 1, and you can able to expect what might be the J and K. In the earlier class itself we have defined. So this is the excitation table, right? So 0 0 0 1 1 0 1 1 are the possibilities. When we are going to have 0 0 as the outputs, what might be its inputs means 0 pi and 1 pi, pi 1 and pi 0. You can go through the earlier, you can get the idea. Now after writing the excitation table as part of the second step, you have to get the JK flip-flop from these two, right? Now observe, you can able to compare these two with respect to this. This is the second step you have to do. Second step means you have to consider this as a present state and you have to consider this as a next state. What might be the values of J and K? See, for 0 0, the J and K are 0 pi. For 1 1, it will be pi 0. For 0 1, it will be 1 pi. For 1 0, it will be pi 1. This is the second step you have to do. right? And the third step is you have to derive the expressions from the given inputs, right? For what you have to derive the expressions? For j and k you have to derive the expression, because you have to have j, k are the internal, and it has to work from the external side for the t, right? So means you have to define the expressions for the j and k, right? So if you want, you can understood what you can do. You can go through the values of j. Values of j are pi, 1 and pi, right? So you can able to, I think there are 4 values only, so you can able to derive it directly with help of two variable k, 0 1 0 1. If I take t and qn, are these two are the inputs, right? Yes, inputs. I have to represent them. So for 0 1 it is pi, for 1 0 it will be 1, for 1 1 it will be pi. So if I am going to construct like this, you are going to get j value as these are cancelled, j value as t. So for j the input will be t. What about for k? K again you have to draw the table t qn 0 1 0 1. For k you have to take these three. For 0 0 it will be pi, for 1 0 it will be pi, for 1 1 it will be 1. So again you are going to take. So for k also it will be t. It will be t. I mean, so how can we draw the circuit diagram for this? So internally you are going to have a jk flip-flop. It is going to produce the q and q bar as the outputs. So t flip-flop, your inputs are going to be like this. This is the corresponding t flip-flop. Right? So this is the implementation of t flip-flop with respect to jk flip-flop. So we can call it as jk2 t flip-flop. Okay, fine. So in the next class we'll try to see how to convert t flip-flop to jk flip-flop.